Hello everyone, and welcome to the Matplotlib Exercises Solutions lecture. In this lecture, we're going to go over the solutions for the Matplotlib exercises. Let's go ahead and jump to the notebook to get started. Alright, here I am at the notebook for the Matplotlib exercises. Let's go ahead and jump right in and get started. I'm going to go ahead and run that first cell to get the data. And let's go ahead and import matplotlib.pyplot as PLT. And set matplotlib inline. Now there's one more question, which is what command do you use if you aren't using a Jupyter Notebook? And as a reminder, that would be plt.show at the end of all your plotting commands. Let's go ahead and start with exercise 1. We want to create a figure object called fig using plt.figure. Alright, so this is just the object-oriented method of using Matplotlib, where we say fig is equal to plt.figure. And then we want to use add_axes to add a set of axes to this figure. And I'm going to go ahead and say ax is equal to fig.add_axes. And we actually get the position we wanted at 0, 0, 1, 1. And then finally I wanted to plot x comma y on that and run this. Okay, looks like we have a good match here. And we want the labels and titles to match below, so if we go ahead and set that in, we want it to say set x label to be x, and then ax.set y label to be y, and we also want to set the title, and it should have just been a simple title. Alright. So what did we do here? We went ahead and created a figure object, added a set of axes to that figure object, plotted on that figure object, and then set the x label, the y label, and the title. Let's go ahead and move on to exercise 2, which is a very similar exercise. We're going to say fig is equal to plt.figure to create the figure object. And then we want to put two axes on it, ax1 and ax2. Let's go ahead and say ax1 and ax2. And I'm just going to say fig.add_axes. First one is located at 0, 0, 1, 1. That's the larger one. And then the second one is located at 0, 0.2, 0.5, 0.2, 0.2. Let's go ahead and run that. And it looks like we get a same result here. Great. Now continuing on with this exercise, what we wanted to do is plot both x and y on both axes here. Let's go ahead and add that into this cell. So I'm going to say ax1 plot xy and ax2 dot plot xy. And here we have the same plot right here. If you wanted that to be red, you could have just added in the color argument red. You can just pass in a string, and now it will be red to match this lower plot. And then if you wanted to, you could have also added in the x labels and the y labels. Let's go ahead and move on to exercise 3, which was to create the plot below by adding two axes to a figure object at these specific canvas points. Alright, so not as much guidance now on exercise 3. First thing I want to do is create a figure object. So I'm going to say fig is equal to plt.figure. And then the next thing I want to do is begin to add those sets of axes. I'm going to say ax is equal to fig.addAxes. And we'll put them at the same locations that were requested at. And we'll say ax2 is equal to fig.add_axes. And we'll set these at 0.2, 0.5, 0.4, 0.4. Alright, running that, looks like we get the same results. And then coming up next, we wanted to use the x, y, and z arrays to recreate this plot below. Let's go ahead and check out that plot below. I'm going to comment these out and bring this a little closer so we can see it. And let me zoom out a little bit. Okay, so it looks like we have a couple things going on here. In the outer plot, we have x versus z. Let's go ahead and add that in. So in the large plot, which is ax in our case, let's go ahead and plot x versus z. And I'm actually going to set the labels for that. So the X label, set X label, set that to X, and then X dot set Y label, set that to Z. So again, this is the large plot. And now let's go ahead and talk about the insert plot. So if we take a look at what the insert plot has going on, it's going to be X by Y over here, and it looks like the title is zoom. So I'm going to go ahead and say X plot XY, and then I'm going to set the title to be zoom, and I'm also going to go ahead and set those labels to be X, and then for the Y to be Y. And we're actually not quite finished yet. Let's go ahead and run this and see what difference we get. So note right now, I made a mistake. This should have been on the insert. So this should have been X2 for all of these. Now let's go ahead and run this. And this is looking okay, but there's still a difference here. Notice on the zoom, the X and Y limits. So X goes from 20 to 22, and Y goes from 30 to 50. Here we're just using the default limits. Let's go ahead and change those on the insert. That's going to be X2 dot set X lim, and we want to go from 20 to 22. Let's go ahead and add that in, 20 to 22, and I'm also going to set the Y lim. And if we scroll back down, we can see the Y lim went from 30 to 50. So we'll say 30, 50 in this list, run that, and now we can see that we're matching completely on both the insert and the outer plot. All right, now we're on exercise 4. Let's go ahead and use plt.subplots to recreate this plot below. I'm going to say fig, axes is equal to plt.subplots, and I want 1 row by 2 columns. Let's go ahead and run that. And it looks like we get that output correctly. Now we want to plot X and Y and X versus Z on the axes, and wanted you to play around with the line width and style. Let's see if we can match these up correctly. I'm going to go ahead and plot over here. Let me empty that out. And let's go ahead and say axes of 0. Remember, we're using subplots now, so we're going to be able to iterate or call the sequence of the array of axes. So I'm saying axes 0 plot, and it looks like I'm going to go ahead and mess around with this. We'll say xy, and on axes 1 we'll go ahead and plot xz, and let's go ahead and set these colors. So we'll set color for the second one to be red, and it looks like the line width is a little thicker. And then on this one, the first one, looks like, let's go ahead and set the color to be blue as a string. And it also looks like the line style, ls, is a dashed line. I'll go ahead and add that in. It also looks like it's a little thicker, so we'll put in lw equal 3. Let's go ahead and run this, see if we get everything looking okay. All right, not bad. It looks like we're getting a match. And now we wanted to see if we could resize the plot by adding in this fig size argument. Let's go ahead and check that out. Remember, we can just add fig size arguments into the subplots call. So we can say fig size is equal to, and it looks like we want wide and short. So we want the first number to be larger, so some wider number such as 12, and the second number to be smaller. So we'll go ahead and say 12 too. And if we run that, looks like we get a match to the second plot over here. And it also messed around with the styles a little bit, so it switched it up on us. We can go ahead and do that ourselves. We just say something like ls over here is equal to dashed lines. And now we switched it and matched it. All right, that's it for the exercises for Matplotlib. Hopefully it really drilled in as far as the syntax for using object-oriented Matplotlib. All you have to do is say, call the figure, add axes to the figure, and then plot on those axes. Or if you're using subplots, as in the last problem, call fig, axes to plt.subplots, and then iterate through those axes or call using the array of axes to plot on each particular subplot. And that's really all there is to it. Go ahead and review the solutions notebook in case any of this was unclear, or feel free to post a question to the Q&A forums. Thanks everyone, and I'll see you at the next lecture.